Alright, hi guys, welcome back to the video on the Heredity and Inheritance chapter. So, in the previous video, right, what we did was we actually went through what exactly are genetic diagrams. We also went through this thing called a Punnett square. Okay, how to use these two tools to help us exactly examine how monohybrid inheritance takes place, and allowing us to know whether the expected ratio of the offsprings should it be 3:1 or 1:1, or depending on what you are actually crossing in terms of the parents. Okay, so today, right, actually we're going to delve a bit more into the third objective, which is to state why observed ratios tends to differ from expected ratios. But you realize that in this lesson itself, right, we'll be doing things a bit different from the previous few videos. In fact, most probably there's nothing much for you to write down in this set of notes. So first and foremost, we are going to do a bit of true and false to get our brain working and warm up. Okay, so first and foremost, the genotype big T small t is homozygous. Is this statement true or false? Okay, this is quite a simple and straightforward question. So in this case, it's a false statement. Why? Because as long as you have these two different alleles, right, together, this is what we call a heterozygous genotype. Okay, I hope you still remember this. Next, if big T is dominant to small t, then the genotype big T and big T small t will have different phenotypes. Now once again, this statement is false. Why? Because phenotype refers to what exactly are the observable traits they are looking at. And in both cases, since there's already the big T within the genotype, you expect both to show the same phenotypes. Okay, so in this case, both of these genotypes, although they are different, right? One is homozygous, one is heterozygous, because they both have the dominant allele, so both will show similar phenotype or the same phenotype. Okay, I hope you are following so far. And the last one, a parent with genotype big T can only produce gametes containing the big T allele. Now, if you recall in your genetic diagram, if this is the original genotype, okay, it can form the individual alleles. And in this case, yes, it can only produce big T alleles, and this statement is true. Okay, so this is just something to get you to get started and recap a bit about what you went through in the previous few lessons. Now, this lesson itself, right, we're going to do things a bit different. We are going to try to make babies and see how this actually allows us to tell whether the ratio of the offspring really can follow or it differs from the expected ratios. Now let me explain a bit more about what's going on. To do these activities, right, you actually need to take some stuff from your home so you are ready for the next few steps. First, okay, we are going to try to do genetic cross, but we're going to do it in a bit of a different manner. Basically, I need to prepare a piece of paper for you to write down your observations, as well as a 10-cent and a 20-cent coin. Okay, I need you to have a 10-cent coin as well as a 20-cent coin. Why? So you can differentiate between the two of them. Because one of the coin is going to be the dad, the other one is going to be the mom. Okay, it doesn't matter which one is the one. Basically, one of the parents is a 10-cent coin, the other parent is a 20-cent coin. So what exactly am I trying to do? I want you to imagine right now that these two parents, right, are actually heterozygous. So you have a big T and a small t for this parent 1, a big T and a small t for parent 2. Much like your coin, basically in your 10-cent coin, right, there's a head and there's a tail. Okay, let's take it that the head itself represents the tall trait, which is the big T, and the tail itself represents the short trait, which is the small t. Now you realize that each parent has its own head as well as its own tail. So likewise, each parent should be heterozygous in this format, because each parent will have the big T as well as the small t. So how do we simulate the entire mating process? Okay, so assuming that small t is the allele for short trait, big T is the allele for tall trait. Okay, so all the heads that we'll be flipping later on, which is represented by this one, okay, you might have a different set of coins that might look a bit different from this, but basically the one with the logo or the crest of the Singapore sign, right, let's take this as the head sign itself. The other one that shows the number or the value of the coin, right, let's take it as the tail. Okay, so the head represents the big T, the tail represents the small t. So what we are going to do, we are going to flip the coins. Okay, and during each cycle, this is what we are going to do. During each cycle, flip the 10-cent coin first. 10 cent represents parent 1. Okay, 10 cent represents parent 1. Flip it, record whether you got a head or a tail, because head represents a big T, tail represents a small t. So you just record on your paper, for instance, first cycle. Okay, say this is a 10-cent coin. Okay, let's say you flip, you got a head, then you write big T. Okay, next, flip the 20-cent coin once and record the data. So the 20-cent coin, let's say you flip it again, you get head again, and that's a big T. Okay, so far? So that is your first cycle. Together, this will give you a genotype of the offspring, which is big T, big T. This shows you that, okay, the offspring is big T, big T. What is this thing trying to represent? Basically, each time when you flip the coin, right, you are deciding which gamete goes down to the offspring. Because the parents are big T, small t, and big T, small t, right? That means they can form either of the gametes. But just like what you learned in genetic diagram, it's a random cross, it's a random fertilization. So it means that you cannot decide which one should be the one. So how do we decide? It's a 50-50% chance. So you flip a coin, and if you get a big T, it shows that, okay, then this big T gets to move down to the offspring. If you flip a coin, you get a big T on the other side, that means this one goes to the same offspring. Hence the offspring will be big T, big T. This is what we're trying to simulate in this entire activity. We're going to try to do this for 20 cycles. So in 20 cycles, right, you should be able to complete all your data until the 20th cycle. And after this, what's going to happen is that you do need to key in your data to the link that's being provided in this assignment. Key into this Google Sheet. Just key in your own set of data, look at your own set of names, and see what the data sheet help you compute out as your results. Then you can see for yourself, overall out of the 20, so imagine this shows that the parents, right, have 20 children. Okay, each time they have one, then this entire cycle repeats. Each time they have one, this cycle repeats. So after 20 children, right, we look at the entire set of 20 children, and we see for ourselves whether there's a certain pattern in it. Okay, so this is the purpose of this activity. So remember to key into the link. Okay, let me show you a short demo of what should happen at home. Okay, remember to use two different coins. Let's take a look. Alright, so as you can see from the video itself, right, that's how you should be conducting your experiment so that you can see for yourself what is going on. And don't forget to key into your Excel sheet, to key into the link that's been provided that you can see from here. Yep, and with that, let's take a look at what does this activity plans to simulate. Do you know what's the expected genotype ratio at the very start? Think about it for a second. If the parents are big T small t and big T small t, heterozygous, if I draw a Punnett square to show you how the cross might look like, okay, remember in a Punnett square you can just cross it out in this manner. Okay, let's say that this comes from one parent, big T, and another small t. This came from the same parent. The other parent will contribute the other big T and small t. Right? In your Punnett square, this will give rise to big T, big T, big T, small t, big T, small t, and small t, small t. Now, these are the types of genotypes that can come up because they are showing the alleles. So, what is the expected genotype ratio? Is 1:2:1. 1 set for the big T, 2 for the big T, small t, and 1 for the small t, as you can see over here in this Punnett square. If you transfer this into phenotypes, now phenotypes means that you're looking at either tall or short in this example that we're doing. Which means that out of all the tall compared to the amount of short that I can have, in this entire Punnett square, it shows me that out of the entire possibility, right, there can be 3:1 ratio. This means that 75% of the offspring total is likely to be tall. 25% of the offspring total is likely to be short. Okay? Hope you can follow so far. So, what exactly is this trying to show? This means that your total results of everything should sum up to show you that the ratio of tall offspring to short offspring must be 3:1. That is what we are calculating using a Punnett square. This is what makes it exact. But if you look at it in your own results, you need to think for yourself, does your results actually reflect what exactly is supposed to be in this aspect ratio? Because if your experiment is done correctly, then shouldn't it make sense that you should end up with a total of tall to short being a ratio of exactly 3:1? Alright, and this is something that we are thinking about as we go along for this entire topic. And that's all we have for this particular video, because when we meet again, when the next lesson starts, okay, we'll go through this set of data that you have. But right now, there's a second set of video that you need to watch, whereby it leads on from where we stopped after this component. Goodbye.